Okay, can you hear me? Okay. Good morning, everyone, and welcome to my talk on Windows Phone application security. So, let me introduce myself. My name is Luca de Fulgentis. I'm the CTO at Secure Network, which is a security firm based in Milan, Italy. And I used to be a web application pen tester, but nowadays I'm mostly involved in the managing of our security services. And I'm also a contributor of the OWASP mobile project, and in the last 2 years, I share my results concerning the Windows Phone application security. And so let's start just with a little introduction. Well, back in 2014, I started investigating and collecting a series of security issues related to the application that target the Windows Phone platform. We then try to categorize these examples of insecure code, and also we map the issues against the Mobile Top 10 for 2014, and statistic on our concerning our results as we share with the OWASP mobile project, for definition of the top 10 for the 2015. Then we decide to extend our research because during the first step of the study, we only target application developed with the Silverlight technology. So we decide to also analyze something like 160 more applications that has been developed with the Windows Runtime technology in order to cover all the security, or better, the insecurity or potential insecure usage of the API that are provided by the Windows Phone SDK. So this talk is all about the result of the study, and I will use as a driver the top 10 list for 2014 because the one for 2015 is not yet ready. And so let's start with the first risk. The first risk is the weak server-side control. When I'm asked to talk about Windows Phone in general, mobile application security, and I start with the discussion on server-side security, everybody simply say, "But are you really kidding me?" And no, I'm not kidding anyone. The point is that even in case of mobile application security, the server-side security is a very important factor. It's a very important aspect because the backend that is used by our application code could be directly attacked by a malicious user, and if the attacker is able to steal the data that are stored on the backend, most of the time, this data belong to the mobile user itself. Moreover, the backend functionality could be abused in order to hack into the mobile application. Once again, try to steal private data related to the mobile user. But by the way, my research has only been focused on the mobile side. So let's move to the second risk, which is the insecure data storage. With the insecure data storage, we are just referring to a clear text storage of any kind of sensitive, confidential, private data. Okay, so with these terms, I'm referring to, I don't know, any kind of password, username, password, so account credential, authorization token, authentication token, and so on. The problem is that if we store in clear text this information on our device, and if the attacker or a malicious app has a privileged access to the file system, well, they can extract this information, which are in clear text, and maybe they can abuse the information. So encryption is very important in this specific context. By the way, the Windows Phone platform, starting from the version 8, introduced the BitLocker technology in order to provide a built-in mechanism to perform the encryption of the disk. The bad news is that the BitLocker feature can be enabled only if we use our device in an enterprise context. We need to plug our device in something like, Exchange, something Microsoft-related technology, Magic, and we have to enforce some policies in order to enable this additional security feature. And so once again, in the Windows Phone universe, the encryption of the data which are stored on the device is a very, very important, is a crucial security requirement, in my opinion. So when we are dealing with the storage, well, this is common even also with any other kind of mobile platform, but with the Windows Phone, we have the, at least we can store information on the file system, and we already know that we need to encrypt data because BitLocker is disabled by default. We started from the version 8, we can, starting from the version 8.1, we can read and write data on the SD card. The version 8 can only read the data which are stored on the SD card, but once again, the data are not encrypted, or they may be encrypted if the application apply proper encryption mechanism or use a proper encryption mechanism. And of course, we can also use any kind of third-party cloud services in order to store our information. And we have at least two problems. The first problem is the security in the transmission of the data. So we hope that our data is transmitted over an encrypted channel, HTTPS, by using HTTPS, for example. And we also have to take care about the security of the data which is stored on the cloud storage server. That's because, well, in case of breach of the security of the cloud service, our data may be stored in clear text. So once again, we should also encrypt our data if we want to we use this kind of services, external services. By the way, during my research, as first, I tried to identify each and every location where you can place any kind of data. And so when you are performing code review, or you are a developer to review your code, you should take care about the different places in your phone where you may use to store the data. We have the local data folder, but the local data folder, roaming, temporary, and cache are sandbox folders. So only my app can only the app that owns this folder can access this data. We also had a package installation folder. We can write data inside the installation folder, but we can read we can basically read, an app can basically read its code. Well, we also have other places such as, the media library, once again, the SD card, or application settings file which are stored as clear text files into the file system. So when the previous table was referring to the Windows runtime technologies, we have some differences with the Silverlight app. So different physical path and different files where the application settings, as for example, are placed. By the way, when we are asked to hunt for insecure data storage, my suggestion here to have a look to a series of methods, classes, and properties they are try to map, and then could be that represent some meaningful keyword that it should be researched inside our code. So now let's move to a real-world example of insecure data storage. In this case, we have the save credential method. The save credential method, which is used to store as inside the application settings file the username and password which as user provide. And as I told you before, the application settings is not an encrypted file, so we are placing some confidential into the file system. One more example, in this case we have a save state function which simply save the cookies, the session cookies of the application, once again inside the application settings, and once again in clear text. So my secure coding tips for this kind of problem is that if you have any kind of confidential private data, you should always apply proper encryption before storing the data on the device. We also have to apply this encryption for every kind of files. even for local databases, which are some mechanism that is provided by the platform. So we have an interface, SQL to, link to SQL that you can use in order to use some local databases. Even in this case, the data which are stored into the SD file, the SD file is the name of this extension of these databases, should be proper encrypted. By the way, the system, the platform also provide us the data protection API, which are a built-in mechanism that should be used to preserve the confidentiality of the data. And for the password storage, the best option is using the password vault. Password vault class. That's because the password vault is storing in an encrypted way our credential in segregated region of our file system. Okay, so we are the third risk. We are insufficient transport layer security. It's pretty easy. We are referring to the confidentiality of the information which are exchanged between our application and the backend system. So the system that the application usually is using to sending and receiving information. In my experience, the most critical issue represented to the transmission information over an unencrypted channels. For an example, using the HTTP protocol. It's a very common issue. It's an issue at least for two reasons. As first, we can intercept the traffic, which is obviously transmitted as unencrypted data. And the second risk is that we can perform a man-in-the-middle attacks in order to manipulate the traffic which is exchanged between the app and the backend system themselves. So this is an example. You can read about this, something like Italia Mobile banking app. They use Danish backend. So is a real-world example. And basically, we have the web browser control. And think about the browser control, just like a web view. Is a sort of web view for it is provided by the Silverlight technology. We are feeding the web browser with the content, which is delivered over with the HTTP protocol. And so basically, the web brew will render the login HTML page. If the attacker can perform a man-in-the-middle attack against this mobile application, it can basically manipulate the layout. It can replace the login page. It can steal the victim while the victim is typing the username and password. So another important issue is, so we may have some further issue with this specific risk, or which are related to this risk. When we are dealing with the digital certificates, Windows, starting for, or better, the Windows Phone 8 implements a nice feature. Basically, the platform discards every kind of invalid certificate. And that's a very strong requirement, in my opinion. It's not so bad, but there is no way to disable this behavior. I mean, you can just invoke or set any kind of flag in order to disable this behavior inside your app. But with the introduction of the version 8.1, Microsoft introduced a specific class that allows the developer to disable some kind of exception related to invalid certificate. Not all of these exceptions, these issues can be ignored, but fortunately can be ignored. But it's still a way. So we are still to take care about how the developers whitelisted some kind of exception because it may introduce some problem, some security problem, of course. So in this situation, I can still see at least two ways to akin to or to break to violate the confidentiality of the exchange data. The first is if I simply send a malicious certificate to the victim and I induce the victim to install the certificate. And the second evil option would be to hack into a certificate authority and forge some valid certificate. And the way we can protect our app and our user from this kind of threats is to pin the certificate, pin the remote certificate, and with the term, I mean, place inside our app some information that can be used by the application itself in order to validate the remote certificate. Basically, we can embed in the app sometimes it is used the certificate as a copy of the original certificate itself, or the public key which is used for the crypt sign, and so we can revalidate the certificate. By the way, with the Windows Phone 8, we have some problem in implementing the certificate pinning. We have to use external library. That's the only option. But Microsoft introduced some classes that allow gathering the information about the delivered certificate and then perform the desired validation. Okay, so when we have to hunt for a problem related to the transport, my first approach, my brutal approach, is to grab for the URI class, and usually I'm looking for the use of the HTTP protocol instead of the HTTPS. So basically, just by grabbing your code with this keyword, with the URI, string, you can spot a lot of bugs. By the way, there are a lot of methods that accept URI, and you should basically carefully audit each and every of your methods if you use this kind of way to communicate with your remote backend. So I just summarize in these tables, which are a different way an application may communicate with a remote system, and basically the methods that I'm proposing accept the URI object, or we have some property that can be assigned to URL. Okay, so what about the secure coding tips? It's pretty simple. We just have to use TLS everywhere. Implementing certificate pinning is a good option, even if it requires some more effort in handling the certificate, because in case of, well, where you have to replace your certificate, you also have to release another application with a new embedded certificate or key that used to validate the certificate itself. So we have much more effort if we implement, but it's the only option to prevent the kind of attacks that I showed you before, that I mentioned before. So let's move to the M4. M4 is an unintended data leakage. That's very simple. That's very simple. Basically, we have our operating system that leaks data. We have this involuntary data exposure caused by some kind of side effects. The side effects that may be, system caching, system logging. So we don't have the application that is writing some sensitive data inside a log.txt file, but where the system that is logging something that may be some sensitive information, an example. And the problem is that most of the time the developer doesn't know the underlying working of the system, and so the system itself introduces these problems. And my suggestion is to have a careful look to the methods that are involved in an example, when you change the state of your application, when you deactivate, when you close the activate, when the application is suspended. That's because when the application changes state, the methods that are included in the table are invoked, and these methods should also implement something like a cleaning mechanism in order to clean, the cache data, any kind of logged data, and so on. this is an example, it's a very common example, when this is the way the developer usually implement the methods that are invoked when the application is deactivated or is closed. There is no implementation at all. So basically, if you have an application that is using WebView, and during the life of the application, the system itself is caching some data, and if we deactivate or close this application, the cache data, or I don't know, it's the stored cookies, still exist inside the file system. And so basically, what can we do? We have just to invoke all the method before closing, before suspending. We have to invoke the method that removes this kind of information. Okay, so we are now at the M5, which are probably related to the authentication authorization. It's something very bad. As first, we are referring to some security decisions without the server-side engagement. So it's something that a decision that die inside our apps. And in my experience, the two most common issues are authorization issue, when you have something like related to the access of critical function. With critical, I mean something which is, I don't know, premium function, or function that allow the access to confidential data. And basically, if you can bypass the authorization mechanism of the app, we can access directly apps, these functionalities or data. The second main problem main issue is represented by a weak generation of authorization or authentication token. I mean, client-side generation of the token. And I can show you some nice example. The first is a snippet of code related to a backup, a contact backup application. Basically, we have this application that allows us to create a zip file containing all our contacts, and the file is created inside the application sandbox. And also, the application is running a local web server, which is listening on the port TCP port 5656. And so the user, if a user wants backup the contact, the user just have to point the browser to the web server and download the zip file. The problem is that there is no authentication, the access of this web server, over the file that contains our contact. So if the attacker can connect to the web server while the web server is running, the attacker can download the zip file without providing any kind of information, any kind of account credential. So this is an example or authentication issue with the client-side code. By the way, that's another very common problem. I mean, the generation of authorization token. In this case, we have basically a static secret. I mean, embedded secret. So everyone can simply download the app and decompile the app and then access the secret. So it's not a secret at all. It's just a string inside the code. And so we have this string which is concatenated with, I don't know, a parameter, but can be tampered. And the resulting string is then hashed with the MD5 algorithm. And the resulting string is then used as an authentication tokens. So the problem is that, as I told you before, the attacker may download the app, may reverse the logic, and then may forge valid authorization token in order to violate the security of the backend. So when we have to hunt for this kind of mechanism, this kind of issue, my suggestion is to have a look to methods, classes, and properties that are available to obtain any kind of some data that may identify the device by itself, such as the name of the device, some hardware ID. I'm also suggesting to look for the use of hashing functions. So I think that these tables are a sort of tool that we can use while analyzing our code. So sometimes, in my experience, most of the time when we have an hashing function, well, there's something wrong. So maybe not, but we should have a careful look at why the developer used the specific algorithm for hashing something. Geolocation coordinates are also used to authenticate users. Sometimes it's a weak mechanism, so we still have to be sure that this information are not involved in authentication or authorization processes. Okay, so we have our secure coding tips. The first is that, well, I don't want you to client-side generate authorization on authentication mechanism. Okay, that's another, it's a good rule. But if you have to identify, not authenticate your device, my suggestion is to use the publisher, basically this property, because this property is unique per device and per publisher, while the device unique ID is unique only per device. So if you have a good app and a malicious app, and if the good application is using the hardware identification, the one which is only unique per device to authenticate itself against a remote system. And we also have another malware application on the same device. The malware application can just read the value of the unique per device string, and so the application can then forge the authentication. The application holds the authentication token. So it can just violate the authentication of the remote system. If you have a per device and a per publisher information, well, the malware should also be published by the original publisher. So the attack scenario is something like you have to hack into the publisher account, and then you have to publish publish an malware application, then trigger the user to also install the other application. So something a bit crazy. By the way, let's move to the M6, which is referred to the broken cryptography. And we have two different aspects related to the broken cryptography. The first is the use of weak cryptography. The weak cryptography, both the use of custom encryption algorithms, the use of vulnerable encryption algorithms, an example, broken ones, exotic way to encrypt, exotic strategies to encrypt data. I'll show you an example. And we may also have some problem related to the encryption process. An example, if you store the key of the encryption key in, the same place where the data that we are encrypting is placed, or if you store the key inside an unsafe area of the file system, or once again, if you embed the key inside our code. As I told you before, if you place a secret inside the code, that's not a secret. You are just giving anyone the secret itself. But anyway, so a simple example, a common example is used, as I told you before, is the use of an embedded key, which is then used for the generation of for the key initialization vector, definitely encrypt with the asymmetric algorithm, something that is so. Once again, if you have this kind of solution, well, we are not properly encrypting our data. And this is the famous example of exotic encryption, where the user, or better, the developer, is using the UTF-8 encoding for encrypt the data, which are then stored on some system, application setting, something like that. So well, this is not encryption at all. But okay, when we have to hunt for, when we have to hunt for this kind of problem, well, once again, we have to look for the hashing function, because hashing is not encryption, and well, we have to have a careful look at this kind of algorithm. Moreover, we have to look at the use of symmetric encryption algorithms, because most of the time the developer also embed the key of the algorithm. And also have a look to places where the encoding is used maybe to encrypt reserved information. Well, I have a mantra for you for today, for your life, which is, do not store even encrypted critical data on device. Even if this kind of mantra will destroy the, can I say, the user experience of your app, you know, it's a trade-off. That's my mantra for today. Another mantra is serialization. In general, encoding is just a data, or better, information representation. It's not encryption. Okay, so once again, the use of built-in mechanisms such as the data protection API should be the best way to encrypt and then store our data on the mobile device. Okay, now we are on the client-side injection. Client-side injection, the same are very, very similar to the server-side one. We still have an interpreter. We have, if we have an issue, we are capable to feed the interpreter with some untrusted data and modify the behavior of the interpreter in order to violate the confidentiality, the integrity of the handled data. The data which are handled by the interpreter or the underlying system. We have different kind of injection, client-side injection, depending on the type of information that the representation information that we are parsing, we are executing, or the syntax of the command that we are providing to the interpreter. Okay, so. In my experience, we have to try to divide the table for the hunting, basically in what we have to look for when we are looking for the HTML JavaScript injections. We have to carefully look at the web browser controls for the Silverlight technology, the web view for the Windows runtime. We may also have the XML injection or any other kind of attack against the XML parser. So basically validation, and we should disable the DTD parsing. The same for the XML and also for the SQL. Well, for the SQL, SQLite is not provided by default, but we have external libraries that can be imported and used to store data using an implementation of SQLite. And so I just summarized the methods. They accept a SQL statement as a string that can be concatenated with untrusted data. It should be validated before providing to the method themselves this information. Same for the methods and classes that handle the name of files, because we want to avoid any kind of injection, path injection, something like that. Well, just a final example on XSET was an application that basically is accepting some user type data and simply concatenate this information to this HTML, the body of these HTML pages, which is then provided to navigate to screen that simply populate the web browser view with this HTML data. So we can type in XML, what else? We can find the words. We have to just type an XSS payload inside the form of our application. And we can just pop up an alert. Or sometimes we can also read the data which is stored on the file system. Okay, final tips. Very simple: validation, 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 validation. That's pretty simple. simple if you have to write a slide, not so simple if you have to implement this kind of mechanism. But by the way, we are at the M8 security decision via untrusted input. And so basically, we are dealing with the inter-process communication. And with Windows Phone 8, we have, starting from the version 8, we have two different mechanisms. The first is the file association. The second is the URI association. We can associate an app with an extension or a URI. And basically, you can allow another app or the system to run a specific application that registers the file type with the URI. Okay, that's an example. We have a PDF reader. A PDF reader register the file type .pdf, or better, the extension .pdf. If you are navigating a website or we are downloading with our favorite browser a PDF file, the system will simply open the application associated with that extension. So very simple. And basically, the idea, if you can provide to the application some input in the form of a file, in the form of parameter which is provided with the URI, so you can you may attack this with this application. So it's just the way we can specify the associations. It's not cool, but let's move to the hunting part. Hunting part, well, once again, we have a series of methods which are invoked when we are opening the target application. So if in my example, the target application was the PDF reader, okay? So we have to, basically, the idea is that we have to implement, once again, positive validation in the parsing of, an example, the PDF file, which is then rendered by which is open and proposed to the user. And also we have to authorize the execution of that method, because sometimes we may, the target methods or the target feature may require some kind of authorization, or we should implement a layer in order to properly defend this kind of the access to these functionalities. Okay, improper session handling, very simple. We are dealing with some session handlers. We have an application that authenticates again something. The backend deliver a session token, and then we have a problem with the handling during the life cycle of we have a weak or improper life cycle for the specific authentication token. Basically one of the most common problems that I found in my investigation was the implementation of lookout mechanism that properly invalidated the cookie on the client side, but the code didn't involve the server-side mechanism. Just like when you have a web application, you have a fake lookout, they just clean the cookie which are delivered which are stored by the browser, but does not call any kind of HTTP/logout to the server side in order to destroy the server side session. Okay. And so the tips is simply that you have to look for tip and fix. You have to look for every use of the cookies, and then careful look if from one side we have the proper cleanage of the data on the store, and if a server-side logout is involved. Okay, just last risk, very quick. Is the last, but very interesting. Well, basically, I skipped some slide, but basically we want our app to be able to self-defend from malicious user. Whereas with self-defend, we want the app to prevent from external runtime analysis, from code modification, from reverse engineering by, once again, the malicious user, application cracking, and so on. I have a nice example, but we have no time, so I have to skip. I'm sorry, but the slide, the web paper will be available soon. And so I just want a final note on encryption. So when you download from the store your application, the application is encrypted. The application is encrypted by the Windows Phone store, but it is decrypted during the installation phase. And then the binaries, the DLLs, just reside on the file system in a clear text. So if you can jailbreak, but unlock, it's the proper term in the Windows Phone universe. So lock your device, you can extract the code, decompile the code. But this is not a problem. But the nice thing is that with the Apex application, which are the Windows Runtime application, the applications are not encrypted at all. So you are not required to have a privileged access to your device in order to extract, to access the original binaries. You just have to go to the Windows Phone store, look for your favorite app. We are hosting in Italy the Expo, so I just want try to download the View Expo News. Okay, so we have a link. Download and install manually. We can download the app, and then we can use our unzipping utility in order to open the zip and extract all the binaries. That was a problem that was also that store had in the past, back in 2012. They still have this kind of problem for a subset of the application. Okay, so what about remediation? My best suggestion is always to encrypt your, if you use this tool just like this, we can encrypt our code, obfuscate our code, introduce anti-tampering, anti-debugging mechanism. Certificate pinning is well, we already discussed about certificate pinning, but with the M10, the idea is that certificate pinning is a tool is utility in order to slow down the analysis by the attacker. We're not dealing with the confidentiality or the identity of the server. Okay, so final consideration. There is a nice option that allows the developer to prevent installation to SD card. That's because there is a bug in implementation, and I'll show some exploitation techniques concerning this vulnerability at the Black Hat Mobile Summit in June. So I can share you my secret for now. And as a final note, I'm suggesting to have a look to the reverse engineering and code modification prevention project, which is an amazing resource for a series of architectural principles in order to securely design our application. Okay, so takeaway. Next week, I'm releasing my white paper. I also give a talk to the Hack in the Box. The white paper will better discuss all the API, all the stuff that I try to show you during this talk. So thank you very much for your attention.
Okay. Thank you. We have time for one question. Okay. Last one.
Is there a tool you would recommend for browsing the file system for the app on the phone?
Excuse me?
Is there any tool that you would recommend for kind of like browsing the file system?
You should have a privileged access. I mean, you have to unlock your phone in order to navigate. You have to use a bug to navigate the file system. There's also a bug for the Windows 10 phone that still exists to navigate the file system, but it's not a utility. You can just access your application sandbox files. The isolated storage, navigation to extraction to something like that. Is one utility provided with the SDK.
Okay.
But no, it's a bug if you are able to. It's just a jailbroken device. Okay.
Okay, thank you. Sorry, we're out of time, but
okay.
Please contact Luca.
Thank you very much.
During the breaks. Thank you, Luca.
Thank you.